And today's session will be shorter than we normally do. I have another session immediately following it, so it'll be a little shorter. What I'd like to cover, first of all, are there any questions that you may have that you want me to touch upon? Okay, if you do, you can open your mic and just say it. And in other words, in any case, I will continue on what I want to cover today. Okay, what I'd like to cover in today's session are two things. One, again, a little more use of our automation. And I also want to cover the issue of synchronization. What do I mean by synchronization? Synchronization is, let's say there's a part that you have that you were working on, you did all the programming on it, and then there's a revision that comes on to the part, and everybody knows that whenever you make a part, there's almost always going to be a revision. And so you want to be able to update all our work we did without having to redefine our operations. You want to be able to, what we call, synchronize our operations, and it'll automatically update and work according to the according to the new revision that we have. Okay. So what I'd like to do is I'd like to start off with this part that we have on our screen. And let me make it just a little bit easier for myself to view this. Let's see, shrink controls. Okay, so what I'd like to do is we have a part over here. If we take a look at our stock, you can see that our stock is just a little bit bigger than the part itself on all the sides. Little excess material on top, about 2 millimeters excess material on all sides itself. Clicking, by the way, on updated stock will show us what stock is actually there at that moment. And like I said, I'd like to use a little more automation. And you've probably seen me in the very beginning of our sessions that I've used options such as the drag and drop. And that's what I'm going to do over here. So the first thing I'd like to do, I'd like to do my face mill. And the reason, by the way, I'm showing you this was because I want you to also get used to, especially when you're demonstrating the program or showing it to somebody, the faster you tool, the faster you're able to put a tool pass on the part, the lot smoother or a lot more interesting your demonstration will be as well. Okay, so I'd like to put a face mill operation over here. So I'm going to take my spiral face mill, just drag it to the top of the part, and we have a tool pass already put on the top. Next, I'd like to, if you take a look at the part over here, I'd like to put a pocketing operation or even an eye machining operation inside over there. So let me just shrink this, all of this collapse all, and just go open up my eye machining templates. And I'd like to do outside roughing. Take this, drag it on the part. And now we've done an outside operation for that part. Okay, let me get rid of the lines so we don't have to see them all the time. I'd like to now work on this pocket over here. So I'll do first a pocket operation with a 10 millimeter end mill with the eye machining for over there. Drag it. Sorry, my mistake. And we have that over there. You know what? I'd like to use this operation I created over here as well onto that face over there. So I'll just drag the operation onto that face. And then we have our operation created over here. Now if I do my simulation from this point on, from the very beginning, and I'll use Solid Verify, you'll see that the face mill was done, the outside was done, the pockets are being done, and of course, this upper step over here was done as well. Okay, now what I'd like to do is I'd like to deal with these holes that are over here. Now, all of these holes that I have over here were created in SolidWorks, what they call Hole Wizard. Okay, just a reminder, if you want to know what Hole Wizard is, let me just open up the part itself. And Hole Wizard is basically a feature in SolidWorks. If I go to feature and we have what we call Hole Wizard, where I can go over here and say, create me a hole that's either, let's say, a counterbore, countersunk hole, a plain hole, a tapped hole, okay, straight tapped holes, and it'll put that feature in according to the actual standards that I have over here. And this information, we also pick up this information inside SolidCAM as well. Okay, I'm not going to save anything. Now, since I'm able to pick up those parameters inside SolidCAM automatically, I can use that to my advantage to automatically also create the type of holes that I want to, the type of operations that I need for each one of those type of holes. For example, this here is a tapped hole. Okay, so I'm just going to drag to this hole over here. And it's going to create the 3 operations that I need to create that tapped hole. Okay, if I just go into one of the operations, you'll see it. I believe I showed this to you once, but I'll remind you again. This is the actual last operation, the tap itself. As you can see, this is an 8 millimeter M8 by 1 tap. And you can see my technology that we're using G84 tapping cycle. Okay, and the levels are automatically put into here as well. Okay, if I want to do the same for this hole over here, this is a 16 millimeter hole. Okay, I'll drag the exact same into this hole, and you see over here we have 2 operations. Okay, here we have a counterbore. I'm going to drag it also to the counterbore itself. And notice with the counterbore, it'll create 5 different operations. The first one being a spot drill, second one, a drill that goes all the way through, third one, an end mill, a fourth one for putting a little chamfer over here, and another one for putting another chamfer over there. And you'll note also it took both of these holes. The reason for that is because these holes were done together in the same feature. Okay. Up until this point, we're okay. Now, remember what I mentioned before is I wanted to talk about also synchronization. And again, if anyone has any questions in the middle, feel free to interrupt me anytime, and I'll try and answer. Okay.
Sorry, do we need to have tapping here? No.
Excuse me?
Those old tapping. We need to do tapping?
The tapping is done.
Okay. Sorry. Okay.
Okay, we have the center drill, the actual tapping drill itself, and the tap. Okay.
Thank you. Okay.
Okay.
Sorry. Yes.
No problem. No problem. Now, I'm going to now close what I've done over here. And I'm going to open the original part. Okay, I'm going to go here, open up the original part. I already have it over here. Okay, this is the original part. Now I'm going to make some changes. For example, let me go into the sketch over here. Okay. And actually, no, this is not what I want to, where I want to make the changes. I'm going to make a change over here, actually. Makes it a little more interesting. Okay. Where is that? That's very strange. Just a second. This, here we go. Edit sketch. Sorry, edit sketch. That was my mistake. Okay. So, for example, this, I've got a revision that says that this has to be 10 millimeters, not 15 millimeters. Okay. And this radius over here is 25 millimeters. Okay. This over here is going to also be 10 millimeters. So you actually see I'm making all different types of revisions in the part. This one over here, maybe this has to be 50 instead. Okay. So as you see, the different revisions I've made inside over here. I'm going to accept this. My part obviously is updated. I'm going to close the part and save it, obviously. Now I'm going to reopen my project. So I'll go to my recent parts and just reopen the project. And you'll note it recognizes that there was a change made to the original part. So it's asking me, it's telling me design model was changed. Do you want to replace it? Now say yes. Okay, so now I'm bringing in the revised part. And you'll also notice now also in the CAM tree, when it opens up, you'll see some traffic lights over here. That means there are options of that with this was affected by them. Okay? Actually, these weren't, but actually maybe it was also. Okay. So what I'm going to do is we have over here, if I right click on operation, we have something here called synchronize all. So I'm going to do synchronize and calculate. Okay. Okay, so now it's calculating all of these other operations over here that had to be updated.
So, sorry, easier. This is what you taught us now about the synchro. How do you say it in English? Sorry. Cyclorite, right?
Excuse me?
This is how you synchronize the model.
Synchronize, right. So you'll note I didn't change any operations. All I did was tell it synchronize, and the toolpath is automatically updated.
Yeah. I see.
Okay. Now I want to do another update, and this is more fun looking. Okay. I have here these holes over here. Okay. These holes over here were the simple holes. Okay. So I'm going to go back to my original part. Go back over here. And when I'm going to make a change over here, in other words, in this feature over here, I'm going to change it from a simple hole to a counter bore hole. And the counter bore hole, let's say I'm going to make it for an M8. Okay? With all these other options, whatever they are. I'm just going to leave it exactly the way the default is right now. I'll accept it. Okay? Completely different type of hole. I'll save it. I'm going to reopen my project. Again, replace it. Okay, there is a little bit of an issue over here. This should not have changed. Okay, I'll check that out a little later on why it changed. But I want you to, in particular, to take a note what happens when I do the synchronization. I'm just going to synchronize now. Remember the simple holes that we had over here?
Yes.
Look what's happening now. Those simple holes, instead of 2 operations, turned into 5 different operations. So it was the operations were completely changed because now it's a counter bore hole, not a simple hole. So he picked that up automatically. So not only the tool, it also changes the tools that's needed for it. So everything here was updated accordingly. Okay, are there any questions about that? This is a pretty nice feature, especially with the whole wizard.
I just have one question.
Yes.
Maybe a stupid question, but if I got a model,
No such thing as a stupid question.
Okay, sorry. If I got a model, okay, for a customer,
Yes.
and I install it into the SolidCAM, and I do a change like you did right now,
Right.
it will keep the original model and the changing one?
The original model is the one that I changed. I changed the original.
Yeah, I know. Yeah, but if you want to go back, let's say that you did a mistake, let's say, okay, and you want to go back to the original model, you can do it here?
Sure. I can go over here.
In the file. Yeah, file. Okay.
Open. I go wherever my original model was, or in the particular case, I can go File. There should be recent parts. Here, go Open recent parts and open that up. I don't have to close my project. I prefer closing the project, but you don't have to close. The moment you do save, I didn't make any changes now. The moment you do save, and then close this, okay? It's always advisable usually to close this as well, to synchronize it. However, let me know what, I can go, actually, there is no synchronization involved over here in this particular case. I didn't make any changes. Okay, but it's always, I would always close my project. In general, it's always better to close the project and then open up the part and then just reopen the project again.
Yeah, new one. Yeah, okay.
Not a new one, just reopen the project. Okay, now some people may ask the questions. Okay, let's say I want to keep the original revision, the original one plus the revision. Okay, how would I do that? Okay, so let's say this is my original. I would do something like this. We have here an option, okay, this one over here that says Save As. Or if I right click over here, I can also do save as. And I'll save this as Rev A, whatever way you want it. So now this SolidCAM project, okay?
Yeah, now it's clear to me. Okay, I understand.
Now it's Rev A.
Yeah, yeah.
Okay, so I have the original
Hey,
one, then I have this, and then when I make the change and I open this, okay. So now I'm going to make the change that I had. Okay, I'm going to go back into my part. Okay, and whatever change I'm going to make right now, just go over here. That's edit feature. Sorry. I can do that also, but I just want to edit sketch. Edit sketch and whatever. I'm just going to make one little change over here. Make this one over here 15. Okay. I'll close it. Oops. Sorry. I'll close it. Even though it wasn't a perfect change, but you understand what I'm trying to do. So now when I open up, let's say I want to open it up in this one. Okay. So over here, I'll say yes. And now it's updating this particular part, this particular project, as you can see.
Yeah, this one is with the 15. I see the cap over here. Yes, yes.
Exactly.
Yes, yes.
Exactly. You can also see that over here.
Yeah.
Right, exactly. Now, if I were to close this one, okay, and go back over here and open this one, the original one, and I don't want to change over here, I'll say no, don't change it. And it'll keep the original revision one. Okay, this way I have two different projects. Okay, so the issue of revisions is very easy to work with when working with SolidCAM, because we recognize the changes of the features, and instead of redoing the toolpaths and rebuilding our operations, we just synchronize. Now, there are cases, obviously, that sometimes you may have to go and make changes inside your operations in any case. For example, if for some reason I made this pocket was changed, and the tool that I was using was a larger tool, and now I made this pocket smaller, and the smaller tool can't go in here. Okay, so it'll give me a change over here, but it won't change the tool for me in that particular case. And therefore, I may have to go back into the operation and change the tool I may want to need. But you'll see that also as it happens also, because you'll see a toolpath that doesn't cover everything, or you may even have an empty toolpath because the tool cannot even go in there. Okay, so but
it will give you a sign. Sorry, easier. So it will give you a sign that you need to change the tool, because if not, you're going to damage the part, right?
No, you won't damage the part. If the tool cannot go in here, I'm just going to go, for example, let me just calculate it over here. Let me just calculate these operations. Calculate.
Oh, you're right. Anyway, you're going to see it on the...
Okay, so what happens is if I were to, I'm going to do something obviously completely stupid. I like to do things like that. I'm going to go into this operation over here, where I did the pocket inside over here, okay? And I'm going to change my tool, my end mill, instead of a 10 millimeter end mill, I'm going to change it to a something ridiculous. I'm going to make it a 50 millimeter end mill, okay? Something really ridiculous. Obviously, I'm not going to do that, but just to show you what happens when I have a tool that's not exactly meant for this particular area over here. What happens? No toolpath was created because the tool can't
Now
go
it's
there.
clear. Okay.
Okay?
Yeah.
So that
Yeah,
works
yeah.
out. Okay. Okay. Like I said, today's session's only going to be until 3:30, as I have a session following this. As far as the next session goes, excuse me, I haven't set a date yet. If there's anything in particular you guys want to learn about, please, please, please let me know. I'm going to see when I can get someone in over here from us to show you also about turning operations, not just milling, but turning as well. But that will be somebody else. And that is basically it for today. Obviously, I did record this, and later on, I will send you the recording and the part as well. So if there aren't any more questions, we will call it for today. Okay. Okay. All right, everyone, take care, and I will send this out and with the next invitation.
Thank you very much, Sydney.
You're
Thank you very
very
much.
All right. Bye-bye.
See you again. Bye-bye.
Thank you very much. Bye.
Bye-bye.